All right. Hi, everyone. Welcome to the last day of Build. Happy to see so many of you are awake after the party last night. It is 12:30, so that's to be expected. We're going to talk today about building line of business and cross-platform apps with mobile services. My name is Chris Reisner, and with me is Donna Meliari. Just to kind of give you a brief overview of what we're going to talk about, we're going to start by just giving a really quick recap of what mobile services is. By this point, after it mentions in the keynotes and other sessions, you probably are familiar with it, but we will just kind of a quick recap. We'll then dive into actually some actual scenarios and examples, such as doing offline, your options for going cross-platform, integrating with Active Directory, doing push notifications, on-premise connectivity, and then at the end, we'll have some time for questions. So just to kind of recap what mobile services is it's a turnkey backend to make it really easy for when you're building different applications on the client side to connect to the stuff you want to do on the server or on the cloud side. So stuff like identity, knowing who your users are and what they have access to, being able to store data, messaging, sending notifications down to devices, as well as logic. These are all capabilities you kind of want to need to have when you're building mobile applications. Mobile services is this really easy way to kind of bridge those together. So at this point, I'm going to hand it off to Donna, who's going to talk about a modern mobile services line of business app.
All right, so show of hands, how many of you have played with mobile services, either by going through the quick start or actually deploying something for real? All right, and how many of you attended the talk yesterday about the .NET backend with mobile services? All right, so I'll just cover some of the basics then. All right, so this is a very simple mobile services line of business app. You may recognize the sample from the talk yesterday. There's also something similar in the keynote. So basically, this is a very, very, very pared down line of business app for a cable technician who works at the phone company, a division of Fabricam. They also make microwaves. I just have a very simple data model here with a customer and a particular job. And this is the online version of the app. So let me go into one of these items, and I'll edit it, and I'll say service is totally out, save it, and to prove to you that I really did just edit it for real, I'm going to go into SQL Server Object Explorer, which you can get to from Server Explorer if you're not familiar with that, and we can see here, if I magnify, that it did actually save. Now, what is this actually doing behind the scenes? Well, it's pretty simple. The mobile services is designed for you to be able to write your client app really easily and not have to worry about your backend. We're basically handling all of that logic for you, which of course you can customize as you need. But if you're a client developer, you don't want to be worrying about your server and if it's on and your database and how all the connections are working. We're trying to manage as much of that as possible for you so you can focus on your app logic. So let's go to the code here. Let's stop the app. So the basic way that you connect to a mobile service is that you create these table objects on your client that represent the table objects in the mobile service. And these are basically just wrappers around this REST API. And that's why we have a great cross-platform story. If you want to use iOS, if you want to use Xamarin, if you want to use JavaScript, PhoneGap, all those things, it all just works because of this common interface. So here we just do get table on a job and a customer. And to give you an idea of what one of the CRUD operations looks like for read, you can do a query using link. Here I'm using order by to sort by the customer name. And it's very easy to get started and to do these kinds of operations. Now I did talk about a field engineer, right? And field engineer, especially a cable repair person, is not always going to be online. And we want our field people and just employees in general to always be productive even when they don't have network access. So we like to split up offline scenarios into two categories. One is where the person is primarily offline. Either they don't have network access at all or they're not connected to the corporate network. So they're actually creating and modifying data a lot and then occasionally syncing back to the scenario, to the server. So we'll call that the occasionally connected scenario. Another common case is the primarily online scenario where you want to maintain a cache of data just in case you go offline or just to speed things up so that you don't have to do a read every time you launch the app, but you don't have a huge cache of data that you've created that you later need to sync. So our goal here is to let you access the data that's in your mobile services tables even when your app is offline. And we want it to work cross-platform. So how we implement this is we keep a queue of all those operations that are modifying the data. And when the app goes back online, we synchronize with the server. We also need to be able to detect conflicts when the same item is changed both on the client and the server so that we don't accidentally clobber someone else's changes when the field person comes back in the office. So overall, our roadmap, and this is not all of this is done in this current preview, but where we're going with this is we want to have a lightweight and cross-platform solution. So the caveat here for cross-platform is that we've released the preview for the .NET client, so for Windows Store and Windows Phone apps, but we're working on previews for iOS and Xamarin. And eventually, we're going to support all of the platforms that mobile services works on. So for instance, JavaScript and Android. And we want to support both of those scenarios that I outlined, the occasionally connected and primarily online. And we want to be able to support multiple backend data stores. If you saw the talk on .NET mobile services with the .NET backend, you saw that it's very easy to connect a backend such as Mongo and use the same APIs that you were used to with mobile services. And so we want to make sure that offline still works. It's not bound to a particular type of data source. And of course, we want it to work with both of our backends, Node.js and .NET. So that is a lot of things. So obviously, we have to give some things up. You can't be lightweight and cross-platform and be as full-featured as all these sync frameworks that you've probably heard of. So we are not a database-to-database sync solution, and it's not intended to supplant more full-featured sync frameworks. One thing to note with these sync frameworks is that they often are specialized to a particular backend store and sometimes even a particular client implementation. So to use SQL Server as an example, if you know your data is going to be in SQL Server and all of the data that you care about is there, and you don't use tables or blobs or Mongo or anything, and on the client, it's a client that does support the sync framework, and you need the full functionality of that, then that's what you should use if you're using mobile services. Offline is not going to our offline feature is not going to have all those features of the sync framework. But if you do need to be able to support multiple clients and possibly multiple backends, then a lot of these off-the-shelf sync frameworks won't give you everything that you need. So one example of another framework is Breeze.js. That's a JavaScript data and offline framework, and I'll show a demo of how that works with mobile services. So in other words, we're giving you an offline implementation, and you're free to use other ones as well. Mobile services works with all of these as well. And because it's a preview release, we've scoped down what we're doing. So we're going to gear it towards occasionally connected apps. It's an explicit model in that the app has to say that it wants to do offline data, and the app has to manually say when it wants to sync with the server. And when I say opt-in, I mean you opt in on the client, not on the server. So if you have any mobile services that are running now, all you have to do is update your client SDK to the latest preview, and on your .NET clients, you can start using offline. And we've added something to both the mobile services SDK to allow for offline data, and also a separate NuGet package that's an implementation of what's called a local store. So in other words, in the mobile services framework, there's an interface for the sync store, and we have an implementation of one that's built on SQLite. But if you don't want to use that for whatever platform you're using, if you want to use some other kind of format, the functionality of mobile services sync will still work for you. In other words, aside from the part that you had to implement yourself for the sync store. And we can also detect conflicts between the client and the server so that we don't do something stupid and overwrite changes when we didn't intend to. And like I said, this is available today for .NET. So let's look and see how easy it is to add offline support to my existing app. So let's go back here. And remember, I had these two mobile service tables, the jobs table and the customer table. So all I'm going to do is change it from a mobile service table to a mobile service sync table. And instead of get table, I'll say get sync table. Now, when I initialize the app right here, currently what I'm doing is just pulling all the data from the server. But the first time you launch the app, you need to set up your local store if one doesn't already exist, and then you need to set up the mobile services API so that it knows about your local store. So I've already written that code. Let me put it here. All right, so if we haven't already initialized the sync context, we're going to use the mobile services SQLite store. We're specifying what file name we're going to use here. And the tables that we want to sync are, in this case, all of the tables that are in our data model, which is the customer and the job. And then we connect the mobile service sync context to this particular store. Now, I need to add a button to actually do the sync. I have one here that's commented out. So I'll uncomment the sync button, go back to my code, and I have implementation. It's a little long, but it's actually mostly exception handling and showing a result to the user. The main part of the code that's interesting are these 3 lines here. So what the sync handler, the sync button handler is doing is that it's pushing all changes across all tables. So that's why it's a method on the sync context and not an individual table, because you might actually have dependencies between what you've been doing if you're modifying several tables in a particular order. And then we're pulling changes for the 2 tables that we happen to care about. In this case, it's the jobs and the customers. And that's literally all you need to do. So let's run the app and see how it's going to work. All right, so notice there's no data. And this is by design. Remember, I said this is the occasionally connected scenario. So you haven't done a sync, so you have no data. So let's sync. So it's going to pull all the data into my local store. And let me change one of these items. So I'll say, for Chris, everything is working now. Now, to prove to you that it really did just save it locally and not remotely, we can see for Chris, it still says service is totally out. Let me magnify that. All right. So basically, it's saving those changes in my local database. And I won't show this now, but if I were to stop the app and relaunch it, I would still see my local data, and it's basically stored in your local app data. Now, the problem is, what if the customer is called up, the cable company, and they say, no, actually, the technician just came and they said everything was working, now it's not. And the technician has this data that he said everything is working. So we don't want to clobber those changes that are on the server, because they actually happened when they happened after the cable person's changes. So how are we going to handle these conflicts? We're actually going to use a feature that already exists in mobile services called optimistic concurrency. And what that means is you can try to write your changes to the server, and the server keeps track of what the current latest version is. And if what the client thinks the version is doesn't match the server's current version, at that point it's going to reject the write. So you don't have to get a lock ahead of time, like in pessimistic concurrency. So you can try to do your write, and the server will reject it if you can't. So in this case, let's create a new value with a value of triangle version 1. That's what the server has. So the device and server are now in sync. And device 2 is going to fetch that same data. Now, device 2 might modify it to a rectangle. The version has now changed on both the device and the server. Now we have a new latest version, version 2. The first device hasn't done a fetch in the meantime, so it doesn't even know that there's a new value on the server. If it tries to change the current value to a circle and tries to update, the call will be rejected, because the server knows that the latest version is 1, and the device is trying to update, the server knows the latest version is 2, and the device is trying to update version 1. And so at that point, you get a conflict that then you can resolve and decide what to do. So let's see how that works. I'm going to stop this app. And in my local store, I still had that change that I made to the customer. And I haven't pushed yet, so the change is only there locally, where I said everything is working now for this customer. So how do I handle and resolve the conflicts? So when I initialize the sync store, basically, I'll specify a sync handler. And this is going to get called when the offline feature is trying to push all the changes to the server. The main thing here is that now you can catch the mobile service precondition failed exception. This is already an existing exception that's precisely for optimistic concurrency. But now we're going to use it to detect conflicts with our synchronization. So basically, what we can do is pull out the current server value by getting the error.value property of that exception. Here we're going to show a dialog box to the user and ask them how they want to resolve it, and that's on the client. If we want to overwrite the server changes with the local changes, what we're going to do is just pretend that we actually did have the latest version all along, and we'll set our version equal to the server's latest version. So basically, we're explicitly forcing the overwrite to occur. Otherwise, if we want the server version, we'll just return that, which is what we got back from our precondition failed exception. So now if I run this, all right, so I'm running this app. I have this change locally where I said everything is working now for Chris. And here I will change it on the server to customer is really, really mad. That's what that says. Okay, so let's go back here. Now the cable person has just left, and they say, okay, now I'm back in the office. Let me synchronize. Everything's working for this customer. And then you get the sync conflict, and you then decide how you want to resolve this conflict. So for the sake of the customer, let's resolve in favor of the server version. So now everyone knows the customer is actually mad. And to prove to you that everything worked correctly, let me refresh the data, and we can see that it has the correct value. Go back to the slides. All right. So to recap, the offline support is lightweight. Eventually, cross-platform. We're going to support all of the mobile services clients that we currently support. We have a preview for Windows Phone and Windows Store. And using optimistic concurrency, you can write a sync handler to detect if the server version and the local client version are out of date with regard to each other. And you can grow into a more advanced sync framework, such as Breeze.js, sync framework, and things like that. So I'll just show a really quick demo of Breeze.js working with mobile services. So this is the standard to-do app, and I'm using Breeze.js to do offline. And so here, I'm going to check off this item, because I'm just showing you right now Breeze.js. And you can see here there's no network traffic in the browser tools. If I go to the resources, I can see that there is, in fact, an item in the local store. If I sync, the item goes away, and there's network traffic. And so that's another example of a sync framework that you can use, and this is connecting to the mobile services backend.
Thanks, Donna. All right, so we've seen offline. It's really great. It's powerful. It's relatively easy to use. Now let's talk about going cross-platform. Now, I'm not going to spend very long on this because I think everybody can understand the value in going cross-platform. Lots of people out there, lots of different devices. It doesn't make sense to just build for one platform and expect everybody to use it when everybody is using very many different sorts of devices. So you've got a few options when we talk about going cross-platform. Well, you could ignore local apps entirely and just build a website, but if that was what we were going to talk about, this would be a different session. So if you're actually building applications for devices, you can use PhoneGap Cordova, and that's a way of doing HTML and JavaScript that's kind of wrapped in a native app, and it allows you to reuse that HTML and JavaScript across different application or different hardware types, but still have access to hardware capabilities. There's also Cocos 2DX, which is it's actually a game framework that you could use if you wanted to build something, and it runs at C and C++, and you can use that to do stuff for different platforms. What we're going to focus on today is Xamarin. Now, you've probably already seen some stuff with Xamarin. In fact, I know you have in the keynotes the past couple days. So just kind of as a quick recap, the idea with Xamarin is it's .NET everywhere. The kind of origins of this were when we released the .NET framework years ago, some really smart people said, hey, we want to take this framework and run it on other platforms like Linux. So they created Mono. And then we created Silverlight, and they tried to create Moonlight and stuff like that. But this has all ended up becoming Xamarin, which allows you to run .NET on iOS and Android devices. So you can reuse code from what you're doing in Windows Phone and Windows Store. Now, there's also capability of tying into native libraries. So if you need to do something that is specific to, let's say, Android, and it's in a jar, you can tie into that from Xamarin if you want to. We're not going to see that today, but I am going to show you a way of basically calling into client-specific platform code. When you use Xamarin, your options are doing stuff in Visual Studio or Xamarin Studio. Xamarin Studio runs in both on OS X and on Windows. Today, we're actually going to be using Visual Studio for building a Windows Store and an iOS project, and I'll show you how that works. One of the nice things about Xamarin is they're really quick to respond to updates and new APIs. So for example, if Apple releases a new version of iOS, Xamarin is usually really quick, like day of quick, to release updates to actually match the new APIs. And the last point here is about PCLs, or portable class libraries. I think if you go back about a year or so, Xamarin didn't have support for PCLs at that point in time, and that meant it was more difficult to really share code. You could still write iOS and Android apps in iOS, but if you wanted to share code, you were kind of forced to copy-paste or do symbolic file links. It was not as easy. When you use a PCL, you can reference the same library from all your different projects and share that code really quite simply. Before we get into actually seeing an example of this, I'll just touch on how the iOS and Android piece actually works. When you're using Xamarin and you're building a Windows Store or a Windows Phone application, you're not really doing necessarily anything different. The difference is really in the iOS and Android piece. Now for iOS, you can't actually put anything in the App Store that really does dynamic code, which .NET's quite good at. So the way Xamarin iOS works is it actually ahead of time compiles an ARM-compatible binary, which you can then run on an iOS device and submit to the App Store. The way Android works is actually really similar to how a normal Android application or even a .NET application works, in that it does just-in-time compilation. So let's go ahead and take a look at a cross-platform app. So, oops, wrong one. So I'm in the portal here, and I've already got the projects downloaded, but just to kind of show you where things are at. When you create a new mobile service, you get this screen where you can choose a platform, and it'll walk you through either connecting an existing app or creating a templated app, which is a to-do application. For this part of the demo, I'm going to use that to-do application, which I've already downloaded for Windows Store and Xamarin. And to do that, you just go in, say, create a new app, and then download whether it's iOS or Android. So I've already done that, and I put both the projects into this solution, and then I ripped out all the references to mobile services as far as the different libraries go, because I don't want to use the specific ones that were already there. I want to share everything. So the first step is I'm going to go ahead and I'm going to create a PCL here, as soon as I find my mouse. All right, so we'll go to our solution. We'll add a new project. We'll choose Portable Class Library, and I'll just name this my PCL. And we'll add that into our project. And the first thing we get is we get asked, hey, what platforms or what frameworks do you want to support? Well, I'm going to do iOS and Windows Store today. If I wanted to do Windows Phone, I could select that. Android is actually automatically selected because if you uncheck that, it's going to say, hey, we're just going to do it anyway because we're not doing anything different to also add Android support. So I'll go ahead and add this. So I'm first just going to get rid of this class because I don't need it. Now the next thing I want to do is actually add mobile services back into my solution. So I'm going to do that via the manage NuGet for packages for this. And I'll just say Azure Mobile. And here it is in NuGet. Now I can install this from here, and it's going to add support for everything for me. So I'll go ahead and install. It's going to ask me what projects I want to add it to. We'll say all of them. It's going to then check for some dependencies. Now, the Azure Mobile Services NuGet has some dependencies in BCL, HTTP, HTTP, and it's just going to install those for me. So we'll wait just a second and let it do its thing. Now, there's currently a small issue with the BCL library in that when we add it like this, I have to do a little modification to my iOS and Android project. I'm going to do that now so you can see exactly what we need to do. But first, I'll just show that if I build this, it's going to warn about some duplicate references in the iOS project. So while it's building, I'll just go up here and start removing them, or get ready to. So here we are, it's saying an assembly of the same name's already there. I can fix this just by removing these. And then the only other thing I need to do is alter this app config. These are issues that happen right now, but we will be fixing those, so it will go away and you won't have to do this added step soon. Let me just copy that. Great, so now that I've done this, everything will compile fine, I can run stuff, it'll work. So the next step is I'm going to start actually putting in the code in my PCL to access my mobile service. Now I mentioned before, I'm using the quick start applications. It's a to-do application, so I'm going to put my to-do data object inside my PCL so I don't have to have it everywhere. So we'll just call this to-do item. And I will use my little snippet here to add my to-do item. So nothing fancy here. If you looked at the to-do application before in .NET, it's the exact same thing. We've just got an ID, we've got text, and we've got a complete field. The next thing I'm going to do is actually add my class, which I'm going to use to access my mobile service. So I'll call this mobile service helper. And inside here, I'll put that. Now inside here, we've got our to-do item table, which is what we'll actually use to access the table. Then we've got an instance of our mobile service using my URL and my key. And then I've got a method to add actually insert the to-do item. Now, I'm not actually adding all the functionality to pull down the items and update them just because it would take more time. But you could really easily add that functionality in here too and then take out even more code from your clients. So the next step after I've done this is I actually need to go into my clients and alter them. The first step to do that, though, is actually to add a reference back to my PCL. So I'll go ahead and do that. So now again, everything's going to compile fine, and my iOS and my Windows Store app are both referencing my PCL. So now I'll go down here to the main page in my Windows Store app. And the first thing I'm going to do is I'm going to take out my to-do item, because again, I'm going to use the to-do item inside my PCL. Once I do that, I need to add a reference over to my PCL so it knows where that to-do item is. The only other thing I need to do here is I'm going to take out this code that's in my Windows Store app to insert a to-do item. And instead, I will add some code to use my mobile service helper to do it instead. So really this code is very similar, if not the same, but now I'm doing everything through the PC, or I'm doing all the insertion through the PCL. So I'll go ahead and save that. And then I'll go up here to my iOS app, and I'm going to do the same thing. So first thing I'll do is get rid of this to-do item, because I don't want to use this anymore. Then I'll go into my to-do service. And I need to do the same thing with the reference here. And then I'll go into where I'm inserting to-do items, and again, I'll do the same thing. Really, this is the exact same code on my client side. I just need some way to call into my actual shared code. The only other thing I need to do is I need to go into the other list view controller, because it also needs a reference to my to-do item. Great, now I should be able to build everything and then run my two apps, and we should be able to see that I'm using the PCL to actually do the insertion for both the Windows Store and the iOS app. So the first thing we'll do is we'll actually start our Windows Store app. We'll deploy it and just make sure that runs. And just to show you really quick, we'll go back over to the portal and we'll see that I don't actually have any data in here. So now my Windows Store app will be running. And I'll say PCL with Windows Store. So I'll save that. And if we go back over here, we're going to refresh. We'll see that the data is now there. Now we'll go back over here, stop that, and we'll actually run the iOS app. Now the way Xamarin works with iOS is that you actually have to pair, well, with Visual Studio rather, is you actually have to pair this with an OS X computer running an app called the Xamarin iOS build host. So basically what this allows you to do is from Visual Studio, you can build and deploy an iOS app, and it's going to actually use everything in iOS to do it, or in OS X to do it for you. So I'll go ahead and switch over to running my iOS app. And I'll change the platform. And we'll go ahead and start this, and it'll actually start up the simulator for me, and it'll launch my app in the simulator. Well, one of the minor issues you might run into sometimes is the host can be a little finicky, so I'll repair that. There we go. All right, so now we will actually try and do that correctly. It's going to take a second. I think it's got to rebuild. All right, well, it seems to be stalled, so I'll just cancel this and move on so we can see the other stuff as it works. So let me kill this. Let's try and cancel. One second, sorry guys. One of the pains of building iOS from Visual Studio is sometimes it can be a little bit iffy. All right, so we'll just go back to the slides and continue on. So the next thing we're going to do is we're going to use a different application that I've already pre-baked, and I've got a solution that has an Android project in it, a iOS project, a Windows Store, and a Windows Phone. Now, this will just show you that we can do all four at the same time and use all four using shared code. So the first thing we're going to show after we actually open it is we're going to show Azure Active Directory. Now, we already saw Azure Active Directory in a couple different situations in the keynote. But we're going to actually show you how easy it is to tie into that using mobile services. One of the great things about Azure Active Directory is that it connects really quite easily to on-premise AD, and I'll show you where you can do that inside the portal in just a moment. When you do that, you also, well, whether or not you tie to on-premise, you get all the benefits of Active Directory, which is the Graph REST API, so you can check on things about your users as well as permissions and things like that, as well as tie into SharePoint, which we also saw during the keynote. One of the other really cool things about Azure Active Directory is that you can connect to other software as a service providers. So as an example, let's say you want your users to be able to log into Box.com with the same their AD credentials. By configuring your Azure Active Directory tenant to connect to that, you can facilitate that. So let me go ahead and switch over again. All right, so like I said, I've got a solution here, and it's got I've got my Android project, I've got my iOS project, and I've got my Windows and Windows Store, Windows Phone and Windows Store projects all ready to go. And to make this whole solution, I basically did the same thing I showed you before, where I created my different project types, and then I just added the NuGet package into them. Now, I'll go ahead and run the project just so you can see exactly what it's doing. But I'll deploy it first. And while that's actually deploying, I'm going to hop over here, and I'll go into the mobile service I've got this connected to. And basically, the way this application is going to work is it's going to allow me to send messages to my mobile service, and then eventually we'll make it so it will deliver these messages down to my users. So now that this is deployed, so really simple data entry. As you can see, I've already got some UI in here for the rest of the demos, but all we're looking at right now is this top part where we can type a message like hello build, and we'll just send this to everyone. And we'll say send. And if we go over here, we should see in just a second that we've got that record. We'll give that a minute because my service is probably just spinning up. And while that's working, I'll go over here and I'll run the iOS app just so that we can actually see that it really does work sometimes. So over here, I'm just going to choose the iOS simulator again. I'll go to my attached devices, and I'll just say I want to run the iPhone 7 simulator. So it shows me the Xamarin. The Xamarin little picture there is just kind of the default launch image when you create an iOS application. So as you can see, it did work. I'm launching my app. We've got the same similar sort of UI. I can say from iOS. And we'll just say we'll send this to everyone. So we'll go ahead and send that. And now if I click here, we should actually start seeing data. So we can see my two records. So again, I've got two different projects, and they're both using the PCL in order to send this, talk to my mobile service. If I go into my PCL project, we can see that I've got this service helper class. And inside here, if I go to The send message method right here, it's using a mobile service table, and it's just calling insert async. So all the functionality to do everything with the mobile service so far is all in this PCL. So let's go back to the portal for a second and look at the Active Directory area. Now I've already created my Active Directory tenant, and I called it Super Awesome Company, so it's already in here. Let's go ahead and look at that. And when you go into your tenant, you can control a lot of stuff like the users, the groups, applications, a bunch of other stuff, including the directory integration. So if you wanted to connect this to your on-premise Active Directory, this is exactly where you do it. Now I've already created my users. I'll go into my application, which I've also already created. Now if we go back to our mobile service, go to Identity, down at the bottom we'll see Azure Active Directory, and by default we'll already have an app URL inside of here. When you go to create a new application for your Active Directory, it'll basically say, hey, what is the URL we're going to tie to? Once you create that, you'll get a client ID. That client ID you just paste into your mobile service, and now you're good to go. You can call in from any mobile service client to authenticate with your Azure Active Directory tenant. So from the client side, to authenticate, authentication is something very interesting when you use the mobile services client flow. If you haven't seen it before, when you authenticate with a provider via mobile services, it pops open a web view, and that goes to whatever the authentication page, whether it's Azure Active Directory or Facebook or Twitter or anything else. You authenticate, and then it returns you to the app. Now, the interesting thing about that is that each platform, whether it's iOS or Windows Store or the other two, they have their own specific way of showing this login view to you, and that's very specific to the platform. So that's something that you really can't put in this PCL at this point in time, because you actually have to do something on the client side. So I've created this platform-specific class here in my PCL that is an abstract class. And inside this class, I've got some methods that specify, hey, what platform is this? And then also, here's an authenticate method that isn't defined. And then from each of my client applications, I actually will go in and I'll inherit from the platform-specific class, and I'll specify how the authentication works. So I'll go ahead and uncomment this right here. And from the Windows Store side, I'm basically going to pass to this authenticate method the actual instance of my mobile service client and then a UI object. Now on the Windows Store side, the UI object isn't used for anything because the mobile service client in the Windows Store library doesn't need it. All we have to say here is go ahead and log in async, and we'll pass in Windows Azure Active Directory. Now, when it comes to iOS, things are a little bit different. If we go to the iOS specific class and go to the authenticate method, we'll see that we actually have to do something with the UI object. We cast that to a UI view controller. And that's because specifically for iOS, when we say, hey, go ahead and show the authenticate view, it needs to have access to the UI, basically the page or the UI that's on the screen at that point in time. So now we're good on the iOS and the Windows Store side. I just need to go back to my service helper and make sure that when I authenticate here, it's actually going to call into my platform specific stuff. So I'm going to go ahead and uncomment this, and basically what I'm checking here is I'll see, is my current user null, or do I have a user ID? If I'm already authenticated, I don't want to show the authentication view again. Then after that, I will call the platform-specific authenticate method, and that will, again, that's going to call back into whether it's the iOS-specific class or the Windows Store-specific, and it's going to say, hey, show the authentication view. Then once that's done, I'm going to call this method, which I'll explain a little bit later when we get to push notifications, and then I'm going to return back to my calling application. So now if I recompile everything, we'll go back here to our Windows Store app, and we'll rerun this. So now I should be able to hit this authenticate method, and it should show me my authentication view. Now again, notice that how it's showing me the authentication view, because when we look at iOS, it's going to be a little bit different. So I'll go ahead and log in. I'm just going to copy that for later. Oops. I think it's just super awesome, maybe. Great. So now I'm authenticated, I'm logged in. And now what I can do on the mobile service side is I can actually lock down everything. So I can say I have to be an authenticated user. That means that my users have to be a member of my AD organization in order to log into this app, in order to do anything. So let's go ahead and go back and actually run the iOS and see what happens there. So I'll go back up here, and I'll set my iOS project as a startup project. We will start that. it's relaunching my application. I'll go ahead and say I want to log in. Now, as you can see there, it's doing something different when it presents that login view. And that's specifically why, for the Authenticate, I have to call that code from each individual project. So I'll just go in here, and we'll log in. And I'll just go ahead and hide my password from all of you. All right, so now I'm authenticated from iOS really easily with very, very little code for each individual client-side project. So let's hop back over to the slides. So the next thing we're going to talk about is adding push notifications into our applications. We're going to do this using notification hubs. If you haven't looked at notification hubs before, they're really awesome for doing hugely scalable push notifications down to iOS, Android, Windows Store, Windows Phone, and I think as of yesterday now, Kindle. So it's cross-platform. It's also one of the nice things is it's independent of storing data in the cloud. So let's say your company is not quite ready to put its data in the cloud. You can use notification hubs regardless because it's just handling all the push notifications for you. One of the really awesome features that we're going to see an example of today is that you can use tags and templates. Tags are a way of saying, hey, whenever you push something to this specific topic or this specific relevant matter, I want to get a push notification. Templates are a way of saying, whenever you're going to send a push notification of this type, this is the format you should deliver it to. That's really great for basically specifying, if I'm running an iOS app, I want to get the push notification in this format. If I'm running a Windows Store app, I want it in this format. Now, the reason that's really important is that every one of those push providers expects a different payload or a different format whenever you get a push notification. Now, the last bit is that you can register from a client side. There's client-side libraries to talk to push notifications and say, hey, I want to register for push. There's also server-side registration where you can talk to your notification hub and say, hey, register this device with this ID for push notifications. And the reason that's important is that we're not actually going to talk to our notification hub from our client applications. And the reason we're not going to do that is from the client application, we could really, we could disassemble that code and we could then change tags and basically register for anything we want, even if that's not my intent as the application developer. Since we can register from the server side, I can lock that down and control exactly what tags someone is registered to. So let's go ahead and add push notifications. Now the first thing I'll show you is that if we go to the service bus area, I've already got a service bus set up. And inside there, we can go to notification hubs. And I've got my notification hub created. Further inside that, I'll go to configure. And inside here, this is where I put the settings for all the different push providers right here. Now I've already set this up and made the application so they have the right manifest and stuff like that for push. So on the client side, I just need to actually start registering for push. So the first thing I'll do is I'll go to my iOS app, and down here, in the finish launching method, I'm going to say register for remote notification. This is the code on my client side that says, hey, go talk to APNS. This is another area where it's specific to the client. There's nothing you could do in a shared PCL to say register for push. Once I register for push, I get a push identifier back, which is a token that for APNS will identify my iOS app and my device to them, which I'm going to set as an identifier in my shared PCL code. And then down here, I've just got some codes that whenever I get a push, I'll get a toast. If we actually go and look at the service helper here, when we register for remote notifications, first we're going to make sure that we actually have a push identifier set. Once that's done, I'm going to create a notification hub registration object, which has the platform. So am I running iOS? Am I running Windows Store, et cetera? The push identifier, so for APNS, here's the token. For Windows, here's the channel URI, et cetera. And then my username. Then I'm going to call a new API in my mobile service, which I'm going to define in just a second, called register for push. Then I'll get back whether or not I was registered or not. Before I go look at the mobile service side, let's do the same thing in my Windows Store. For my Windows Store, all we have to do is go in the app class, and inside here, we say create push notification channel for application. That'll get back our channel URI, which we can then set again inside of our client application. Now, let's go over here to our mobile service. And before I actually look at the script, I'm just going to highlight that I've already set a few environmental values in my configuration area for my mobile service. Specifically, I've got the notification hub name and the signature. These are two pieces of information that I need to talk to my notification hub from my mobile service. And the reason they're here instead of actually in the script is so that I can reuse the script without having to worry about the keys and the key and the name being embedded. So I'll go over to the API area, and I'll copy my register for push script. So inside here, I'll paste this and then we'll walk through it. So I'm exposing a post method functionality. The first thing we'll do is we'll pull out the different variables, so the push identifier, the username, and the platform, and we're also going to pull out the installation ID. That's something that's automatically going to be in each of my applications that are using the Mobile Services SDK. And it's basically a unique string that's generated the first time my application runs that will then identify my installation or my application on my device. So the next thing I do is I require the Azure module. And then I create my notification hub service, and I'm using those environmental variables right here to create that. Otherwise, I'd have to have these embedded in my script. So the next thing I do is I define two methods. I've got a registration complete method and a log errors method. These are methods I'm going to pass into something just to handle any registration. So then the next thing I do is I pull out the registrations by tag, and I'm going to pass in the installation ID. The idea here is every time I register, I want to make sure I get rid of any previous registrations. I don't want to have my device registered multiple times with my notification hub. So inside here, I'm just going to delete each of these each registration I might already have. Then after that, this is the really great part. This is where I'm going to check the platform string that came across. And that platform string, if you notice, is something that's in each platform-specific class. So inside here, because each template each format for the push notification is different depending on the platform, this is where I create my template object. And this is basically saying, hey, when I get a push, this is the format I want it in. And then for each individual platform, I call into its create template registration or whatever the create the registration is, and I pass in whatever the push identifier is, so the token, the channel URI, the registration ID, and then a list of tags. And here I'm going to use tags that include the username, the platform, the string all users, and the installation ID. Once I do that, that means that for whatever specific device is registered, if I send a push and say, send it to this username, or send it to this platform, or if I send it to all users, send this to this registration. And we'll see examples of that in a minute. And we can see as you go down, I've got it for iOS, for WinPhone, and for Windows Store. And basically, I'm just saying, hey, do a toast. And that's going to handle all the registration for push notifications for me. So I'm going to save that script. And I'll return back to here, and what I'm going to do is I will go ahead and run my Windows Store app. And I'm going to authenticate again because I didn't put in the code to actually save my credentials, so I'll do that really quickly, or as quickly as the internet lets me. There we go. All right, so I'm authenticated again. And now what's great is that because of my client-side code, I basically said, hey, as soon as you authenticate, go ahead and register for push notifications. So if I actually looked at the notification hub, we'd say, I've got a channel URI, I'm subscribed, it would have my tags, it would have my template. It'd be great. So now in here, I'll say hello, and I'll say I want to send this to WinStore user, because as you can see, that's my username. So I'll send this, and what we should see in just a second, hopefully, maybe I missed something on the client side. 1 second. Let me try to get that working correctly for you. Let's try that again. We'll authenticate. So it looks like I'm not actually try this one more time, and then we'll give up and move on. after this, we will give up. All right, so now we're actually hitting the breakpoint, so we should be getting a push identifier. So we'll just make sure we're getting that back. All right, so we are actually getting a URI now, so this time it should work. All right, so we'll try this again. I may have done that. Let me check one thing, and then we'll just move on because we're running out of time. And registering for the push notifications. So I apologize. I did register for push, as you can see from the logs here. We actually get the registration back. This should be working, but for whatever reason, it doesn't like me today. So the last thing we're going to talk about is on-premise connectivity. So for on-premise connectivity, we're going to talk about using Service Bus Relay. Service Bus Relay essentially allows you to talk to a URL that's being hosted in Windows Azure, Microsoft Azure, and that will basically pass it right back through to something running on your premise. And this is really great because it means you don't necessarily have to open firewall ports, which can be a bit of a headache. So from the client side, you can run an application that says, hey, Service Bus Relay, whenever you get information, go ahead and send it down to me. So in this situation, what we'll do is our client application will talk to our mobile service. Our mobile service will then talk to the relay, and that relay will be siphoned to a console application running on my computer. But in reality, that could be anything running on premise, whether it's a line of business application, could be a web service that gives you database access, whatever you might need to do. So let's go ahead and actually see that working. So the first thing we'll do is we'll shut down this application, and we'll go and I'll run this other application that we have right here. And what this application is right here is it's just a web API that I'm going to run in a console app that will say, hey, Service Bus, here I am. While that's starting, we'll go over here to our Service Bus. We'll go back here to Relays, and we'll see that we don't have any relays at this point in time. So if I go in here, it's a very simple API. All it's going to do is going to create an array of users. This would be my contact list. It's going to convert that to JSON and just send it back to the calling application. Inside here, I've got a Service Bus Relay host, which actually has some of the more complicated code of saying, hey, Service Bus, here I am. This is what you want to talk to. So we'll go ahead and run this application. All right, so it says it's open, and it says it's listening at the chat demo.servicebus.windows.net/web API. If I go back in here and I refresh my relays, we'll see I've now got one relay. It's hosted. It's there. I can now talk to this, and when I do, it's going to go back to my console application. So now what I need to do is go back to my mobile service. I'm going to go to the API, and I've got this getContext API that I just need to implement. So I'm going to grab the script for that. This script is really simple. It's going to use the request module to basically make an HTTP request. I've got the URL of my Service Bus Relay right here. All I'm going to do is invoke this request and then return the result back to my calling application. So on the client side, this code is actually something where it's completely the same on all the platforms. So let me restart that. Whoops, wrong one. There we go. So this is a situation where the code is exactly the same on all of our platforms because all we're doing is talking to our mobile service. So if we go down here to getContext, all we're going to do is basically say invoke this API and return the result. Now, one thing that is interesting is because this is UI driven again, we do have to actually load it on each client side. So if we go back to our main page at XAML and we call getContext, here we're pulling that out using our service helper, and then we're setting it to a drop-down list on our screen. If we go up to the iOS app, we'll see something very, very similar, which is It's right here. We basically create a view picker model and show that, because that's the iOS basically way of doing a spinner or a drop-down list, whatever your preference is for calling it. So now that that's done, let me go ahead and rebuild my application, and we'll rerun it. And now what we should see is, because I put some code in my console app to basically log a request whenever it goes to my console, what we're going to see in a minute when I run this and I say get contacts is my request will go from my Windows Store app to my mobile service to Service Bus Relay and then back to that console app, and it'll log something and say, hey, I got a request. So if I say get contacts and we go over here, no, not my day for the Windows Store app, unfortunately. I'm just going to go ahead and run the iOS app, which I know will deploy correctly. For whatever reason, it's a little finicky whenever I'm deploying to Windows Store via Parallels. So we'll just run this. It's going to relaunch my application. Shortly. Let me try restarting that. Sorry, folks. All right, so now it's actually going to relaunch. And if we hit get contacts now, oh, maybe that, nope. All right, well, clearly I'm having some connectivity issues of some sort. Yeah. My apologies for this. Some of the demo's not working. I'll have all the code out there so you can try it yourself. You know, I'll tell you it worked an hour ago, but I'm sure that's not much consolation. Anyway, so let me go back to the slides here. So just kind of a recap. Mobile service is becoming a lot friendlier and easy to use for line of business apps and stuff that you need to connect to your on-premise, whether it's service via Service Bus Relay or using Active Directory and stuff like that. We've got great new features like offline data sync, Azure Active Directory support, really easy integration with notification hubs, as well as Service Bus Relay. Xamarin makes it easy to reuse your .NET code and really trivial to call into specific application-side stuff when you need to. And everything I showed you today from JavaScript that should have worked or did work can be done from both the .NET backend you can use with mobile services as well as the JavaScript I showed you today. So we've got some links, and I've got I'll give you a URL to the slides in just a minute, but we've got some different resources. Some of these are sessions, some of these are tutorials created to show you how to do some of the different things we did today. Like I said, I'll make sure these slides are available so you can actually get the links, since you clearly can't just click on that right there. Here's our contact information. Feel free to contact us at any time and ask questions. We'd love to hear from you if you're trying to implement any of these solutions and help you get there. The last thing is your feedback's important. We appreciate you guys coming, and we'd love to hear about your thoughts. So please fill out the evaluations. Thanks everyone for coming to Build, and we'd love to take any questions you might have.